Okay, welcome to tutorial 14. This is our last tutorial video. In this video, we're going to walk through the Cournot duopoly, which is a Cournot model of quantity competition with two firms. Once we get through that, we will take this model and extend it to any size market. And we'll look at the cases where we have larger than two. But the nice thing here is with the Cournot oligopoly, the solution we arrive at even applies to cases with a single firm in the market. So we'll walk through and talk about how Cournot nests monopoly, duopoly, and perfect competition all in one model, just depending on which n we choose. Okay, so we're going to keep this pretty light here. There's going to be some math, but the main idea is to apply our concepts of game theory to what we've to what we're building up here. And this is our last tutorial. And what we're doing here is really coming full circle. Just as sort of an outline, we first started off the class building up the demand curve. So the first couple of weeks, we modeled individual optimization decisions using a utility function and a budget constraint. We used sort of similar concepts when we jumped over to the firm side, so the other side of the market, to build up the supply curve. And because there are many types of market structures, we started off simple by setting up the firm's optimization decision in the perfectly competitive market. Then we jumped into more complex environments with monopoly. But with both of those two environments, the firm's individual decision-making didn't depend on what other firms in the market were doing. So most of the time, we expect there's some strategic interaction between firms. And I guess maybe I shouldn't say most of the time. A lot of the time, there is strategic interaction between firms, really depending on how the market is set up. So to more accurately reflect the world we tend to live in, what we're doing here is setting up the ability for firms to strategically interact, where we say one firm's best decision influences another firm's best decision. And we did this in the last tutorial video by introducing the tools of game theory. And what we're going to do in this video is apply them to a quantity competition model, what we call Cournot. Okay, so that's sort of where we're going full circle here. We started off with the consumer, we built up the tools of optimization, we applied those tools to the firm in simple environments, and now we're ending with the complex environments with strategic interaction. So what we're going to do here is first start off with a Cournot duopoly. And to set it up generally, we'll start with sort of our definition of Cournot oligopoly and apply it to two firms. With the Cournot oligopoly, firms are competing over quantity. So firms choose their quantity, which then plays into how much quantity is in the market affecting the price. And the price is what determines the firm's profit. So we're assuming firms are profit maximizing, choosing quantity simultaneously. So in the terms of game theory, this is a static game. They're choosing their quantities simultaneously, which affects the market price. So let's look at a Cournot duopoly real quick here before we scale this up. So Cournot duopoly. So both firms are aiming to maximize their profits against each other. And for simplicity, in this tutorial, we're going to look at a linear demand curve with two firms. We'll call them X and Y. And we have some marginal cost that's constant at C. So the way we define quantity in the market, the quantity supplied, is just the quantity coming from firm X and the quantity coming from firm Y. So our equilibrium, when we plug in the quantity supplied into the demand curve, we set QS equal to QD, and that gives us this thing here. So we're rearranging, we're plugging in here and rearranging to isolate QS. So this is the equilibrium, the solution to the equilibrium price. So we have price in this relationship, but instead of solving for P, we're solving for the quantity of firm X. So if X were the only firm in the market, we would have a relationship between price and quantity. We would set QSY to 0. And we would have our standard monopoly problem. So it looks something like this. We have this graph on the left. So we have our marginal cost curve. We take our marginal cost curve, intersect it with our marginal revenue curve at this point to find our optimal quantity, QX. We plug QX into the demand curve to get our price. But here, we're not actually a monopolist. We have both X and Y in the market. So what we've solved for here, this equation, is, let me just erase this cross out. What we solved for here is the what's sometimes called the residual demand. It's the demand for X after we've accounted for the demand for Y. And because we're subtracting off this quantity from Y, we actually have a smaller demand curve than we did with the monopolist case. So we've taken some of the demand away from X and we've given it to Y, because Y is producing in this market as well. Okay. Once we've set all this up, we've established the demand for X after we've accounted for Y. We then walk through the same process where we have the marginal revenue curve. We intersect it with the marginal cost to find the quantity. We run that up to the demand curve to find the price. So everything's the same. It just is responsive to the quantity decision of Y. Okay. So this all looks pretty familiar. One way of thinking about this is that X sees itself as having a monopoly on the market that's left over. So the market that's left over after all the consumers have gone to Y that would want to. So sort of a monopoly on the leftover market. But the idea here is that because X responds to Y, this response should be part of how Y makes their decisions. Y knows X will respond by decreasing their quantity. if X increases their quantity. So Y should include this in their decision-making process. So that's the whole idea here, is the two firms are making decisions in ways that affect each other. So the question is, what quantity should each of the firms produce? And that's the main thrust of what the Cornu model attempts to solve. And at this point, if you're thinking about best response functions and Nash equilibrium, that's great. That's exactly where we're going. So we want to find a best response function for each of the two firms and set them equal to each other. So we want to plug the best response functions into each other. That's where we're going. Okay, so the first thing to do is to find the best response function for one of the two firms. So we'll start with Y. Coming back up to this graph here, the best response function for X in this case is the same optimization problem we've always worked with. We want to set MR equal to MC. No matter what firm we're looking at, this is how we choose our quantity. And then we always take this quantity and plug it into the demand curve to give us price. So what we'll do next is first set up the marginal revenue curve. So we have revenue, which is quantity for Y times the price. This piece just comes from the demand curve. We've just rearranged the demand curve to find price. And we've multiplied the two. We take the first derivative with respect to QS, Y, and that gives us this relationship here. A minus the quantity that's being produced by X minus 2 times the quantity produced by Y. Okay, and then we set the marginal revenue equal to the marginal cost and solve, and we get this expression here. And this is our best response function. It's telling us whatever quantity Y produces, whatever quantity X produces, Y should produce this much. Okay, and just as a sanity check here, increasing the quantity X produces decreases the quantity Y produces, which should make sense. As X goes up, the quantity of X goes up, we shift the demand curve in, and our quantity also shifts in. Okay. So the best decision for Y depends on depends on the choice of X. So we don't have a dominant strategy, but we do have a best response function. So this isn't fully pinning down what Y should do, right? Because we don't yet know what X is doing. So what do we do here? We take our best response function for X and we solve for it, which will give us X, the quantity of X, which we can then plug in into our equation. So that's what we're going to do. So all I've done here is flip the subscripts. We know the two firms are identical, so their best response functions are just going to be mirrors of each other. So we find this using symmetry. Take this expression for QS, plug it into this expression, I should say QX, plug it in for QX, and that's what we get here. So this is our substituted value for QX. Then we simplify this, just simply expanding. So we multiply this 1/2 across and expand. So we have negative 1/2 times A minus C minus 1/4 A minus C. And then we have this last part, which is 1/4 times QY. So the thing to note here is we've completely isolated QY. So we have one variable, which is equal to parameters. So we have one variable, and we just need to solve. So we rearrange. We bring this 1/4 QY to the left-hand side, and we combine the two terms of A minus C. And once we simplify our fractions and cross-multiply, we get that QY is equal to 1/3 A minus C. Okay, so this is the solution for the Nash equilibrium, for the quantity choice of firm Y. So all we've done here is equivalent to what we have in our graph. So we have two best response functions. So best response function for X, represented in red, and the best response function for Y, represented in blue. On the vertical axis, we have the quantity chosen by Y, and on the horizontal axis, we have the quantity chosen by X. The Nash equilibrium for this Cournot model is simply where both firms would not want to switch their quantity decision if they knew what the other firm was doing. So it's essentially like anticipating what happens and finding the point that neither firm wants to change after the fact. And there's only one of these points. And that's our Cournot-Nash equilibrium, which comes out to be 1/3 A minus C for both. Okay. So we found the best response functions, just as sort of a summary here, which depended on the actions of our rivals. Then we found the point where the best response functions overlapped at this point. And this is essentially where neither firm would want to change after the fact, if they could. Okay, and this is our Cournot duopoly. Okay, so this is cool. We have two firms. Using two firms makes it easy to sort of set this up visually. What we're going to do next is extend this idea into environments where we have more than two firms. So we're not going to be able to graph it as nicely, but it's the same idea. We find the best response function, which depends on the quantities chosen by the other firms, and we then set them equal to each other. And we're going to keep this simple again. We're going to look at identical firms, and we're going to use a demand function. We're going to use a linear demand function in just a second, but I want to show you how to do this generally without a demand function, and then we'll use a functional form once we need to. Okay, so we have a marginal cost C. We have a demand equation here, which takes quantity, which is the sum of all of the quantities produced by each of the n firms in the market. So this is really just P as a function of Q, which is our demand curve. And we want to find the firm's marginal revenue curve. I'm including this here, this general solution, just for your interest. If you want to skip ahead, feel free to do that once we jump down to the linear demand curve. Okay. So the marginal revenue curve is just the derivative of the revenue, which is the price. So we're looking at firm K, so we subscript everything with K. So we have quantity times price, And using the chain and the product rules, we get this expression. So we have price times quantity K times the derivative of the demand curve with respect to Q. And then all we're going to do here is just rearrange this expression for the marginal revenue for firm K in the following way. So we know that because all firms are identical, the quantity produced by K is just going to be the quantity in the market divided by the number of firms. So we plug that in, and because elasticity of demand is this equation here, we can just rewrite all of this as the elasticity of demand. So all we're left with is this P minus 1 plus 1 over n times elasticity of demand. And this looks familiar, right? In the Monopoly video, we talked about market power in this context, where when monopolists have market power, it comes from the elasticity of demand. When we have a flat elasticity of demand, when we have a flat demand curve, the elasticity of demand is something close to infinity. So this piece here goes to 0. Here, we have the same solution. If we plugged in n equals 1, we would get the monopoly's marginal revenue curve with their market power. And if n is going to infinity, this second component goes to 0 because we have 1 divided by infinity. So we've sort of embedded both monopoly, duopoly, we've embedded monopoly, duopoly, and perfect competition in this oligopoly model, simply by varying n. Okay, so we can't really go any further using a general demand curve. So what we're going to do is go back to our linear demand curve, and we're just going to say the quantity supplied is just the sum of all of the firms' supply in the market. And we're still going to assume all firms are identical or close to identical. Okay. So the first thing to do is to find the firm K's best response function using this demand curve. So we said we multiply the quantity produced by K times the price. So we just plug in QS into QD to give us the price, and we set it equal to C. Once we solve this, this looks a little complex, but essentially all we're doing is just we multiply QK times all of the elements inside. All of the elements except for QK on the inside. When we take the first derivative with respect to QK, they just stay as they were. So we have A minus Q1 plus all of the other Qs. The only place we have to be careful is when we take the derivative of QK squared, we get 2QK. And that's all set equal to C. Using the fact that all firms are identical, we can sort of solve this generally, where we say, let's just use Q for all of the Qs, and solve for Q. So we're using Q without a subscript to stand in for all of the individual quantities. This is a way of using the fact that firms are identical in a relatively straightforward way. There's another way to do this where we try to solve for each of the q's individually and then plug them each in. And that gets really pretty messy. So instead, we're using this little trick where we let all the q's equal each other, coming from symmetry. Okay, and when we do that, we have 1 all the way up through n of each of these q's. So we're adding all of these together. The only caveat, the only place we have to be careful, is with this 2qk. So we have 2 of them, which means we have n elements, but one of them we count twice, which means we have n plus 1. So that's where we get this n plus 1 times q. So we have n plus 1 q's, which makes our lives really simple. All we have to do now is solve for q, and we get this expression here, a minus c over n plus 1. Okay, so this will remind you of the case we just walked through above with the duopoly, where we had n equal 2, and when we plug n equal 2 into our equation, where we had q is equal to a minus c over n plus 1, we get a minus c over 3, which is exactly our duopoly solution. Okay, so what we've done is embed duopoly in our oligopoly solution. And this is our Nash. This is our Nash equilibrium here. What we've done is found the optimization decisions for each of the individual firms. We've used this little trick here, the fact that they're identical, which means their solutions are symmetric. And we've solved for their Q. So this is the optimal choice. And you can see it goes to 0 as n gets larger. But we can run through a couple cases here. When n is 1, we had monopoly, and we got this solution, a minus c over 2. And just like we checked before, when n is equal to 2, each of the 2 firms produces a minus c over 3. The market quantity is just the sum of each of these 2, so we multiply that by 2. And you can see this verifies the fact that quantity is increasing, market quantity is increasing in n. When we go from monopoly to duopoly, we go from 1/2 a minus c to 2/3 a minus c. So we've increased our quantity. For perfectly competitive markets, when we have a very large number of n, all we have to do is take the limit. So we take the limit of n times q, n times little q, which is just the number of firms in the market times each of their quantities. And when we do that, we take the limit of this relationship here, n over n plus 1. All we're left with, so this piece goes to 1, and all we're left with is a minus c. So the last thing here, before we close out, we want to verify the fact that in perfectly competitive markets, the price is set according to the marginal cost. So to do this, we take our quantity in the market, we plug it into our demand curve. So we have price is equal to A minus Q. We plug it in here for Q. The A's cancel, and all we're left with is C. So this verifies the fact that in perfectly competitive markets, the price is set at the marginal cost curve. Okay, so what have we done here? Starting at the top, we used the tools from game theory to allow us to examine the strategic interaction between firms engaging in quantity competition. So firms are choosing their quantity. Their quantity affects the demand curve, which sets the price. And that price affects the other firms in the market. So what we did is we used the idea of a best response function and our concept of firm optimization, where we set marginal revenue equal to marginal cost. So this was essentially just finding the best response function, which depended on the quantity choices of the other firms in the market. And when we took each of the best response functions and plugged them into each other, here, we were able to find the Nash equilibrium, which is the point where neither firm has an incentive to deviate. Neither firm has an incentive to change their quantity decisions. So we did this with the duopoly, and then we did it more generally with any n, and we showed that we could verify sort of nest monopoly, duopoly, and perfect competition all in the same Cournot model using this notion of game theory and Nash equilibrium using best response functions. Okay, so that's the end of Cournot and oligopoly. We will walk through some examples in some follow-up demo videos.